All right, so thanks for that introduction, Paul. What I was going to talk about today, and as Paul mentioned, I'm replacing Cornell, who is the ARRIS CTO for EMEA. We're going to be talking about some aspects of DOCSIS 3.1 capacity planning and performance analysis. There are basically three parts to the presentation. I'm going to kick off with some thoughts about traffic modelling and how to do capacity calculations and introduce a formula that we've been using quite extensively. Then we're going to get on to DOCSIS 3.1, look at the DOCSIS 3.1 toolkit, which I'm sure many of you are already familiar with, and then focus on a specific question because in the previous presentations we've been hearing about it's not that easy to upgrade the bandwidth of your network to 1.2 gigahertz down, 204 megahertz up. There are issues to be resolved. It's likely to take some time. So what can DOCSIS 3.1 bring to an existing network in terms of capacity improvements? And then we'll finish with a look at some recommendations concerning DOCSIS 3.1 capacity planning, and then take a look at how things might evolve in the years to come, and have another stab at the often asked question of how long can HFC last. So, I think to up. So, just to set the scene, there are a number of key challenges to delivering a great user experience, and in this particular presentation, we're going to concentrate on speed. And speed, I think, that's why that first bullet is highlighted. And speed, I think, is the most important single factor contributing to the user experience, because it's something that the user perceives directly in terms of the applications he can run, in terms of how his service works. It's something he can measure using speed tests. And it's also important because it's something that service providers compete on directly with other players in the sector, against telcos notably. So, way back when we were thinking about the required DOCSIS capacity to deliver a given service tier, we used a fairly simple approach, which was a kind of rule of thumb. If you wanted to deliver, say, a 10 megabit per second downstream service, then you would put, say, 20 megabits per second DOCSIS capacity into that downstream. And, you know, with the sharing between the subscribers, that would kind of work. As we move forward, what we feel is that you have to introduce also average bandwidth, not just the peak bandwidth that you're selling your subscribers, but also average bandwidth. And this also has an advantage in the sense that there are different tools when you want to, when you're experiencing congestion due to peak bandwidth or average bandwidth, there are different tools that you bring to bear on those. So basically, what we say is, well, if you want to sell a 200 megabit per second service, the capacity you need to have, if you have a given serving group, is, well, you at least have to have that 200 megabits per second as provisioned DOCSIS capacity. But on top of that, you need to add the aggregate average consumption of all the other subscribers. And when you think about this is actually quite intuitive, because let's imagine in that service group, this one person to whom you've sold a 200 megabit per second service, he's going to do a speed test. While he's running that speed test, he wants to see 200 megabits per second. In order to do that, the pipe has to be at least 200 megabits per second wide, plus it must have the additional capacity to carry also the average bandwidth that all the other subscribers are consuming. And what we'll see later is, as I said, there are different tools for the two types of bandwidth, and typically segmentation, which is an often used tool to improve the capacity of cable networks, will only help you with average bandwidth. It won't help you with peak bandwidth. If you divide that service group by 2, then that 150 megabits of average bandwidth goes down to 75, but you still have to find 200 megabits per second of peak bandwidth. So now we've got that model in mind, let's kind of set the scene by taking a look near term at maybe how far we can go with DOCSIS 3.0. So this is just an example, but hopefully, averaged over a certain number of cable operators, it's a fairly realistic one. We've taken, so the average bandwidth is the orange, and the peak bandwidth is the black. The orange, we just let it grow, 50% year on year. That seems to be a fairly common figure, and it's something over which the service provider has little control. That's just going to keep growing. Something the service provider has control over is what peak bandwidth he wants to sell. That's a marketing decision. So what we've taken here, just as an example, is, let's say, 2015, the top-tier peak bandwidth, 200 megabits per second. 2016, 500. So there's a lot of talk about 1 gig, so we probably want to get there by 2017, 2018, which means selling top-tier downstream service speeds of 1 gigabits per second. And then maybe because we start getting some PON competition towards 2019, 2020, let's just up that a little bit to 1.2 gigabits per second. And what we can see, if you look at the corresponding capacities in terms of DOCSIS 3.0 channels, is that even DOCSIS 3.0 can take you up to 1 gig top-tier speeds up to about 2017. But between 2017 and 2018, if this model is to be believed, you will start hitting the capacity of DOCSIS 3.0. And that's when you will need to have started implementing DOCSIS 3.1, at least for those top-tier subscribers. What this means also is that in the network, you're going to be managing a fairly diverse population of cable modems. So you'll have some cable modems that might have only a 4 downstream capability, some that have 8, some that have 16 or 24. So this really just illustrates the fact that the CMTS needs to have sufficient flexibility to be able to accommodate all of those populations and to load share in such a way that that capacity is evenly spread across the 32 downstreams. At the bottom, we show a 32 downstream cable modem. That may actually be the first generation of DOCSIS 3.1 because it's not clear in the industry whether we will actually go beyond 24 downstreams for DOCSIS 3.0 cable modem. So that may actually be a DOCSIS 3.1. So let's get on to DOCSIS 3.1. There's a whole toolkit of features in DOCSIS 3.1, but basically what it's there to do is increase your capacity. And increase capacity in terms of the actual planned capacity you can put in the downstream and in the upstream to address the Tmax issue, which you can't address with segmentation. And in the toolbox, there are really 2 key areas. One is the introduction of higher modulation orders and the introduction of more efficient error correction coding, which basically for the same CNR can give you an improvement of 2 orders of modulation in what you can carry. And then hand in hand with that is spectrum expansion. So down to 1.2 gigahertz downstream and 204 megahertz, even 400 has been talked of upstream. Now, one of the issues, obviously, is the fact that upgrading the physical infrastructure to 1.2 gigahertz downstream, 204 megahertz upstream is a big investment. We heard in the preceding presentation about some of the issues around that, and it's not something that will be done overnight. So it's interesting to ask the question, what can DOCSIS 3.1 give us even without that bandwidth upgrade? Can it give us any significant improvements? And these are some of the questions that we've been getting asked. So the question I've just said, if I turn on DOCSIS 3.1 in my network today, as is, what speed increase will I see? And connected to that is, how do I know what modulation orders I can run in my network today? How can I plan for that? And then a question which we'll address towards the end of the presentation is, given I would say, the increased complexity of DOCSIS 3.0, how does this affect capacity planning? Now, it's important to understand, I'd say, just one fundamental difference between DOCSIS 3 and DOCSIS 3.1. DOCSIS 3 is, in a sense, a fixed technology, maximum 256 megabits per second in the downstream. Either it works or it doesn't. So if you have a network that's just capable of running DOCSIS 3, then you will get a certain capacity. If you have a network that is much better and has several points of MER higher than what's needed for DOCSIS 3, you'll still get the same capacity. And that's one of the things that the designers of DOCSIS 3.1 tried to solve by introducing things like higher orders of modulation and what we're seeing here, which is modulation profiles. So a modulation profile, simply put, is the fact that we recognize that over a substantial amount of spectrum, you're likely to see variable MER as a function of the way the network is set up, as a function of local interference. So they introduced the notion of a modulation profile, which means that in an OFDM channel, you can actually run individual subcarriers at different modulation orders. So you can have some subcarriers running at 1024 QAM, others running at 256, others running at 512, so that you can really fit to the MER curve as closely as possible. There's more than one modulation profile per service group. One isn't enough. And one of the reasons is that you're going to see individual modems will not see the same MER profile. This can be due to a number of reasons. It can be due to one of them is sitting off a node, another is sitting off a 5 amplifier cascade. It can be due to problems with the wiring in the home, the connectors. It can even be due, and this is just an illustration of something which may not be too much of a consideration now, but will be in the future. We're already aware of the potential for interference from LTE. Well, LTE is also following its own evolution curve, and we're likely to see an evolution to very small cells in the future. So what you might see, depending on where your modem is, it will be seeing interference on different frequencies. And so it will need a different modulation profile to take advantage of that. So this is just a simple illustration of how multiple modulation profiles work. Here we can see a simple example of just 6 cable modems and the MER that they are seeing across a certain section of bandwidth. And what you can do is define an MER contour, which is, if you like, the maximum MER you can have, subject to the cable modems functioning without error. So basically what you would do, you take this MER contour, and then that says, well, you know, in this part of the spectrum I can run 256 QAM, in this part of the spectrum 512 QAM, in this part of the spectrum 1024, etc. So this is a very simple example where with 6 cable modems we're generating 3 modulation profiles. In reality, this would work across a complete serving group. So with a complete population of cable modems, however many, might be several hundred, and with a handful of modulation profiles. So typically, you would get a lot more cable modems per modulation profile. And here we're taking the first step along the process of trying to answer the question, that we're being asked. If I have a DOCSIS 3.0 network today, what can I expect from it tomorrow in terms of DOCSIS 3.1? And the starting point for that is to get information already today from the DOCSIS 3.0 modems about what MER they're seeing. So in the next few slides, I'm going to present some results we actually measured on a real network so that you can see what kind of improvements we can expect. And we've actually developed a tool which enables you to take a population of cable modems, read their MER figures, their CNR figures, and then determine what the right modulation profiles are. So I'm going to show you some output from the tool, but first I need to explain what the output says. So each profile is described, as you can see on the slide. So the profile number, the number of cable modems in that profile, the raw data rate. So this is basically, given the different modulation formats along the profile, how much total data rate are we getting out of that profile for each cable modem. And then, even though this is being done on DOCSIS 3.0 cable modems, the framing, the way of presenting the data is according to DOCSIS 3.1. So we have the number of subcarriers in the channel, the spacing of the subcarriers, the center frequency of subcarrier 0, so where the channel starts. And then on the right, you can see how the information is presented. So basically, the first figure is the subcarrier number, and the figure after that is the number of bits in the constellation. So you start with 512 QAM. When you get to subcarrier 320, you go up to 1024. When you get to subcarrier 480, you come back down again to 512. Down to 256 QAM at 640, and then up again to 512 QAM at 960. This is not a 192 megahertz OFDM channel. This is output from an actual network where the customer today is using a few tens of megahertz for his DOCSIS 3.0 downstreams. So we're only able to look at that bandwidth in those modems. So here's an example for a fiber node. So you can see the tool has actually defined, I should say, 4+1 modulation profiles. So there's the baseline profile, which is no better than DOCSIS 3.0. The tool even found that at one point it's slightly worse than DOCSIS 3.0 because normally, it judged that it was not possible to run 256 QAM at the top of the band. And that probably means that in DOCSIS 3.0, it's working, but there may be some errors. And then what this does, basically you can see that differing numbers of cable modems have been placed into the different profiles. For the purposes of completeness, if it's not possible to get measurements from certain cable modems across the whole frequency range, then the tool, for the purposes of the presentation, puts them into profile 0. But when calculating, making an estimate of the capacity, it actually distributes them using the same ratios as the modems that could be read. And here's some actual output we can see from a cable network. So perhaps I ought to explain the diagram a little bit. This is basically a statistical distribution of what I would call a market. It's not just a single serving group because you can see that there are more than 140,000 cable modems that have been analysed. On the x-axis, you can see the data rate that those cable modems are able to get or would be able to get under DOCSIS 3.1 compared to, as a baseline, DOCSIS 3.0, which is 1. And so then you can make a weighted average of those points, and we come up with the conclusion that in this particular example, we get 22% extra gain. Okay? So, a couple of remarks about that. When we show this slide to people, they say, well, 22%, that's not much. it's a number of things to consider. It's not much because DOCSIS 3.1 does go hand in hand with spectrum increase. If you really want to hit those multi-gigabit speeds downstream and a gigabits upstream, you need that extra bandwidth. However, this figure is probably quite conservative because these are DOCSIS 3.0 modems. So the figures they're reporting are not just the plant. It's whatever's happening in the home, the implementation margin of the cable modem itself. Perhaps a DOCSIS 3.1 cable modem will have a better implementation margin than a DOCSIS 3.0. So these figures, if anything, are probably pessimistic. And the actual situation is probably better. Also, another remark, because of all the issues of in-home wiring, it may be a policy of network operators when deploying DOCSIS 3.1 cable modems to say, these can no longer be anywhere in the house. I don't want them sitting behind splitters, bits of coax cable in the home. These have to be at the entry point in the house as a gateway, and then we have other mechanisms for transporting the data around the home. Just out of curiosity, we also did a simplified study where we took away the notion of variable modulation profiles and just stuck to a fixed modulation profile. And so just basically this means defining a threshold below which the cable modem would not be able to work, and then trying to group the cable modems to see whether over the whole band they could still support 512 or 1024 or whatever. And here you see the output of the tool. As expected, it's not as good, 17% compared to 22%. And basically this is because there's less granularity, because the modulation profile is defined in such a way that the cable modem will work at the minimum modulation order for the worst part of the network. So if there's a bad spot in the network and in the frequency range in the spectrum, and then a little bit higher it gets better, the modem can't take advantage of that. It's important when thinking about multiple modulation profiles to think about how they need to be managed, because this is something that has to be dynamic. You can imagine situations where homes might be suffering local interference from, I don't know, local industries during the day, and in the evening, perhaps the environment becomes more quiet. So these modulation profiles, although they may be statically defined, there has to be a way of managing the modems and moving them up and down the profiles as necessary. So this is just an example. This is really implementation specific, but this is just an example of how the CMTS might do this. So in the case of 4 modulation profiles, the cable modems know all the modulation profiles. That's given to them during the registration process. And they try to decode all 4 modulation profiles because they're seeing even the transmissions that aren't intended for them. And then the cable modems are able, via CM status messages, to tell the CMTS to which profiles they're able to lock and to which they are not able to lock. And then the CMTS will always use the highest modulation profile for that particular modem. So if at some point in the day there's noise, the cable modem will signal to the CMTS that it's lost lock on that particular modulation profile. The CMTS will then send to that modem on a lower modulation profile, and then when the noise goes away, the process reverses itself. So I think on a high level in terms of recommendations, DOCSIS 3.0, as we said, has a performance ceiling. It either works or it doesn't. And no matter how good your network is, you won't make it work better. You'll still get the same capacity. So DOCSIS 3.1 has broken that ceiling. That in itself is not enough. We talked about the large upgrade step of increasing the system bandwidth. And that's obviously a big investment that many cable operators are looking at. And that's not something that may happen overnight, not in all parts of the network. But the nice thing about this whole idea of modulation profiles and multiple modulation profiles is that every bit of improvement you do in your network through incremental maintenance, fixing connectors, whatever, leaky cables, all that immediately translates into increased throughput. Also, when you deploy DOCSIS 3.1 cable modems, if you think ahead about how you're going to do that and have this gateway idea where they're really at the entry to the home, where you're in total control of the quality of the signal going into that cable modem, that could also push up those figures that we've just presented. So I think one of the takeaways is that DOCSIS 3.1 breaks the ceiling. And it gives you an immediate return on your network investment, whether that network investment is opening up new bandwidth and turning on that new bandwidth, or just doing maintenance to make the network better and cleaner, or even breaking up cascades, segmenting, getting better end-of-line MER. All that immediately translates into increased performance. But the only way you're really going to see that, I would say, I hate this word, quantum leap in performance, is when you actually open up that additional bandwidth, 1.2 gigahertz down and 204 megahertz up. So now we've taken a look at that. Let's go back to the capacity planning formula and introduce an added twist. In the earlier slide, I was just adding the total average bandwidth to the max bandwidth and saying that's the amount you need. In fact, what we found is that you kind of need a small fudge factor in there, a K. K's one kind of works fine as long as you're sure there's only one guy in your service group at any one time doing a speed test. K equals 1.2. With the service providers we've socialised this formula with, K equals 1.2 seems to resonate better. So you need a little bit of headroom on top of that. So if you turn this round a little bit, and you're asking yourself, well, what Tmax can I propose to my subscribers based on my service group capacity and the average bandwidth? Well, in DOCSIS 3.1, we've introduced a new twist because the service group capacity is no longer fixed. It depends what modulation profile you're talking about. So one way we suggest looking at this is no longer to talk in terms of service group capacity, but to say, how much bandwidth do I need to allocate to sell a particular service? So we basically take the formula and we divide it all by blended average service group capacity per megahertz. So you get to a formula that's about frequency. It's about numbers of megahertz rather than data rates. And here's the twist. What you do is the average part of the formula, you divide it by the average blended capacity, so across all modulation profiles, because that's what matters. That's the amount of the pipe, excuse me, that's the amount of the pipe that's being occupied by all of the cable modems. So everyone's consumption has to be taken into account in that part of the formula. But for the one person who's sitting there doing his speed test and checking he's getting the speed that he's buying from you, you have to take, if you don't know his modulation profile, and in principle you don't because it could be changing over day, then you have to take the worst case modulation profile. Now, that may differ. For instance, coming back to this idea of your deployment policy for DOCSIS 3 cable modems, if you know that all the cable modems that happen to be in profile 0, the lowest profile, are because of in-home wiring problems, and you're deploying your DOCSIS 3.1 cable modems at the entrance to the house where the quality is best, then perhaps you don't need to take the baseline profile. Perhaps you can take profile 1 or 2. But you do need to take into account when capacity planning with DOCSIS 3.1 the fact that you're not getting the same service group capacity per profile. So now we can go back to our famous chart and try and look at where we are with capacity and how long capacity can continue to grow. So to start off, this is just a simple extrapolation at 50% annual service growth rate of both the average and also from where we left off in 2020 with 1.2 gigs. We'll just keep growing that at 50% and see what happens. And I think the only one line we need to worry about is a full spectrum of 1.2 gigahertz DOCSIS 3.1, the maximum that DOCSIS 3.1 can do, and obviously here concentrating on the downstream, but we could do the same analysis for the upstream. So in theory, we see, well, 2024, okay, that's not tomorrow, but it's 8 years away. We seem to be hitting a capacity issue. But that's already quite reassuring. That's still a certain number of years away. But there's things we can do. This is a very simplistic graph where we haven't even considered segmentation. There's no segmentation happening in all this time. If you segment, then that orange portion of the bar will go down proportionately. So that will help. It would certainly help in 2024. If you segment, then you're back down below the 1.2 gigahertz DOCSIS 3.1 capacity. But there are also things you can do for the Tmax portion, where segmentation isn't helping. Typically, this Tmax is driven by top-tier subscribers. I don't know what percentage, the 1% that are buying the most expensive top-tier package. And there are a number of things about that. They're a small percentage, and studies seem to show that the annual growth rate of those services tends to be faster than the lower tiers. So basically, you get to a point where you're dimensioning your whole DOCSIS pipe for 1% of your subscribers. So there are some things you can do, if it's feasible, things like selective subscriber shedding. Perhaps for those guys, there it really does at last make sense to bite the bullet, pull fibre all the way to their home and give them a fibre to the home service. If that can be done in such a way that it doesn't have to be a wholesale upgrade to the network, which would be very expensive, but selectively, if you can take that Tmax out of the equation, the Tmax of the next tier down could be a lot lower. And so that bar would go back below 1.2 gigahertz DOCSIS 3.1, plus the fact that because then that becomes average bandwidth dominated, segmentation again becomes an effective tool. So you can again segment to get that bar back down. All this is assuming also that DOCSIS 3.1, there's nothing coming after DOCSIS 3.1. And, we're already hearing talk of things like full duplex, where by the time you've got your fibre really out to the tap and your last active is driving directly the tap, you can actually consider running bidirectional spectrum on the fibre, on the coax, which you can't do in current networks because of the reflections between the actives. ARRIS has also made a demonstration at a show in the US where we also imagine what could be one of the next steps beyond DOCSIS 3.1 by showing that you could actually take a US-style drop cable and put 5 gigahertz of spectrum down it and have enough MER at the end to run 1024 QAM. So, DOCSIS 3.1 may not be the end of the story. So I think that's where I'd like to finish on a positive note. There may be an end to the HFC story, but it's not happening anytime soon.
Time, so a few questions.
Sure.
I'd like to kick off, if I may, with the worst case profile 0.
Oh dear, you've been taking notes.
Yes. Do you think that's down to bad install practices? If you have good install practices, do you think then that goes away? Home start kits with push-on adapters and all of that?
I think, well, several reasons for that. The number one reason, I guess, is that if you're designing a network for DOCSIS 3.0 today, that's as good as it needs to be. So Profile 0 is not bad, actually. It's good enough to run DOCSIS 3.0. But to your point about things like home installs, what it does mean, this whole idea, the flexibility of DOCSIS 3.1, is that it starts to make sense to invest in cleaning some of that up without doing the enormous investment of doing the bandwidth upgrade. Even incremental investment in cleaning up parts of the network, cleaning up some of the home installs, that immediately translates into additional capacity.
Okay. Please.
Hi.
Question about moving to a gateway device, a single point of entry into the home. Any rules of thumb or experience coming back about what capacity gain that would give?
Oh goodness! I mean that's a very open question. I mean we've seen from some of the earlier presentations that it's almost a non-linear problem. I mean drop cables, a bad cabling inside the house can completely destroy the MER. I mean we've seen some studies also from the US where we've been looking at different scenarios of network quality for DOCSIS 3.1 and looking at some real measurements. And just putting cable modems behind a single splitter for some reason, which I don't fully understand, that brings down the MER. We've seen lovely curves, histograms of network performance, and then when you factor in the home network, they all go down. So I think there's a lot to be done in the home network. It's very difficult to put a figure on it. I mean, it can go all the way from virtually, no effect to it doesn't work at all. And I think, I mean, to Keith's presentation earlier, I mean, there's even with new solutions for F connectors, there's still a lot of old F connectors out there, and that's going to be creating problems. So if you can put the gateway at the entrance to the home, then that helps. But then, of course, you have to address other issues like, well, if I'm bringing a gigabit per second to the home, I have to get it through the home as well. So if your gateway has the Wi-Fi access point in it, then that's not the best place to put it. So then you get into a whole set of discussions about you need a backbone in the home. I mean, there's a lot of hopes being put on MoCA for that. MoCA 2.5, MoCA 3.0 as a kind of wired backbone to hang off multiple access points in the home. But, DOCSIS 3.1 raises a whole host of in-home issues as well.
Please, Mike.
Yeah, a couple of questions, Tony. In your latest slides, you showed that 600 kilobits per second was the average consumption number.
Yeah.
What are the other dimensions of that? Is that per hour, per day, per week? And if so, do you actually have any real marking data to show what's going on in terms of people's average consumption?
Yeah.
Average consumption is bottom layer.
It's very low.
Yes.
Yes.
So that's the one I would question as to how solid it is.
Yeah. I mean, most of the figures we've been getting are figures that I know my colleagues in the US have been discussing a lot with US operators who have ideas about where their average consumption figures are. What's interesting is that obviously compared to the speeds we're selling, average consumption is tiny. And but once you add it up over the whole service group, it becomes important to know what that average consumption is. So, I'd say the figures are reliable in the sense that these are not things we plucked out of the air. These are the figures that we're being told by other operators. I mean, I'm not sure in Virgin Media if you have ideas about where your average consumption per user is or things like that.
We do know 350 kilobits.
Yeah, 350. Yeah.
I mean, back to the point, if I may, the reason behind this is many people know that I'm part of a small wireless internet service provider.
Yeah.
We monitor the stats on our customers. And in the past couple of years, what's tended to be the case is not peak speed going up, but the bytes per week count is going up. So there's more occupancy,
Yeah.
but not necessarily any higher speed. speed.
Okay, yeah.
That appears to be because the residents of the province, so there's a finite number of people there,
Yeah.
a finite number of hours a day, and a finite number of pairs of eyes to watch.
Yeah, okay.
And that's tended to appear to have a sort of clamping effect on the speed increase. But
Okay,
not on the
that's
volume.
interesting. That's interesting.
Leslie, you also have ideas about planning for the upstream. Because, I see someone downstream, but the upstream, we know you go to a 12 megahertz bandwidth.
Yeah.
Does that mean that you, because you will split, of course, the bandwidth with the number of homes.
Yes.
Is it the way that you will start driving 200 megahertz out of one modem, or is it out of an area? So looking into the in-home installation.
Well, I mean, my understanding is the first generation of DOCSIS 3.1 cable modems are going to have that capability of 296 megahertz upstreams. So, I mean, the intent, because, see, the important thing is, coming back again to this notion of peak bandwidth, you're selling a service, and to sell that service, you have to have that capacity, even if on average it's not being used a lot. So, if you only have, say, a modem that's only allowed to use one OFDM upstream, and then sitting alongside a population of other modems needing two OFDM that can use the other OFDM upstream, any one of those is only ever able to burst up to what one upstream can give him. Whereas what you may want to sell as a service provider is a full 1 gigabit per second capacity on the upstream, and for that you need the two channels. So I would tend to see that as potentially, maybe not straight away, but potentially a full 204 megahertz per cable modem.
Okay.
I don't know. I'm sure there are CPE experts in the room that would have an opinion on that. I don't know, Kostas? No? No opinion.
It's a big effect, of course, on the in-home installation. Yeah? If you look to the in-home amplifiers,
Sure,
it has a
absolutely.
big effect if
Absolutely.
you do that or you split it over different houses.
Absolutely. Yeah, I agree.
Would you see that same sort of thing in the downstream? So do you see that as like a sort of a shared spectrum where you would, all your tiers of service would use that whole spectrum? Or would you select certain tiers of service to use some parts of that OFDM spectrum?
Well, my understanding of the DOCSIS 3.1 standard is totally flexible. So you can have, if you have, say, I think the maximum is 5 192 megahertz blocks downstream, cable modems can use the subcarriers in those blocks as dictated by the CMTS with relatively complete flexibility. So I think you don't need to segment your spectrum into different tiers to handle the different service tiers. And I mean, thinking about it, it's maybe not even a good idea to do so, because the tier that's really driving the bandwidth is the top service tier. So if you create separate tiers for all of them, you're essentially lining them up. Whereas if you've got a downstream lineup that's powerful enough to keep your top service tier satisfied, you know, I'm tempted to say that the others, they're perhaps not lost in the noise, but they can be easily handled because it's really the top service tier that's driving the capacity.
I suppose it's more maintenance on the network, though, isn't
Yeah.
it? The more spectrum you've got to manage. Can we start singing? Yeah, I suppose it's more management of the network, isn't it? The more, yeah.
One at the back, please. You're doing a fine job there.
Is this working? All right.
Yeah.
So I've been into quite a few lectures about the becoming DOCSIS 3.1, and one of the things that's a common theme is the complexity of the modulation as a whole and how many knobs and adjustments there are. And it looks like your tool addresses how to manage that. But what's your guess on how long it will take an MSO to optimize all the settings to get the most out of it? I mean, just pick a number out of the air, because I think it's going to be kind of fascinating to see how it looks like when they deploy it at day one, and then how it looks 6 to 9 months later.
Yeah, no, that's a good comment. I mean, there's a lot of flexibility in the DOCSIS 3.1 spec. And just as here, we've actually built a tool to define the modulation formats for you, I think the thinking would be that DOCSIS 3.1 is not something that you would want to try and tweak manually. And despite all the flexibility, I'm not expecting that you would be able to individually set each one of the 4,000 subcarriers in an OFDM sub-channel to whatever modulation format you want. There has to be some kind of granularity. But I think, I may be wrong. I don't believe that's actually called out in the spec. So this is something that's really going to be, a work of definition between vendors and service providers to, what kind of tools are required. But certainly one of the things, everybody talks about the capacity improvements of DOCSIS 3.1, but I would say it's as much of a revolution in terms also of the management tools that are going to be needed.
The device spec, it does actually go on about carriers and the partition between the OFDM carriers. So when you have 25, you can have either 50 kilohertz spacing or, and all the rest of. So there are things that you can change, but I'm not sure whether you'd want to change all the parameters. It's very similar to Wi-Fi or 211 ACNN.
Yeah.
Uses a very similar sort of format, OFDM, etc. A lot of variables.
Yeah,
Good luck.
I agree. And probably it may be a reaction to the fact, DOCSIS 3.0 is already complicated enough, but, with hindsight, it's hard to understand why a hard limit was put on 256 QAM, for instance, that there's nothing else in the spec.
Yeah.
I think maybe the reaction to that, I wasn't personally in those meetings, but maybe it was, make as much of it flexible as we can, and then afterwards it becomes a question of implementation.
I think DOCSIS 3.1 is a lot harder than DOCSIS 3, definitely.
Yes.
Yeah.
Can we just stop there and say thank you to Leslie?
Okay,
It was
pleasure.
appreciated.